Good morning, and welcome to Litmus Test. Last time we looked at elements and compounds and molecules and atoms, and it was kind of all over the place, but we're going to continue looking at those concepts going forward. And today I want to focus on the chemical formulas and the way we write down elements, compounds, and so on. And maybe that'll help clear up some of the things we talked about from last week. We'll see. So first, let's review this recipe for iron picks. An iron pick is 2 sticks and 3 iron ingots. And we say that the name of this thing is an iron pick. We're going to give it a chemical symbol, IP, just as a shorthand because I don't have enough space on signs to write everything out really long. And we're going to say that it has a chemical formula of 2 sticks and 3 iron. So just to review what that looks like, we'll have some wood, make some planks, 2 sticks, 3 iron makes an iron pickaxe. And for the purposes of this video, we're going to pretend that anything that goes in the crafting window is atoms of an element, and anything that goes over here in the product window is some other substance. Alright, so this is a substance called iron pickaxe, and this arrow represents a chemical change. In almost all cases, we're going to pretend that today, when we craft, we're going from atoms and elements into a new substance, so old substances to a new substance, and this represents a chemical change. That this is no longer the same substance, and we know we cannot go backwards, and we know that this has many, many different properties than the original pieces it was made from. Alright? So that's where we're going to start. Let's look at some other examples of this, and let's look at how we can write this down. In chemistry, we usually write this down using the arrow notation. So we might say something like 2 sticks plus 3 iron yields an iron pick. Alright? And we know, remember that the iron pick has this formula that you can kind of make out in the corner of St2Fe3. Now, we could rewrite this a little differently, because we could say, well, those 2 sticks have to be in a certain arrangement. They have to come together, so to speak, in just the right arrangement. So we could rewrite that as if they were a single molecule made of 2 atoms, so stick 2. And likewise, we could rewrite the iron as if it was a single molecule made of 3 iron atoms, Fe3. This is not always the most helpful way to write things, especially since instead of writing IP there, we'd have to write, and I'm going to go down here, we'd have to write St2Fe3. And that's not always the most helpful or accurate way of writing things, but in this particular video, we're going to pretend that these are just 2 elements, right here, just going to pretend that these are just 2 atoms, 3 atoms to make this thing, and we know that this thing has that formula from over here. Now, what are other ways we could combine these in this chemical reaction? Well, we could say we have 2 sticks plus, we could say 3 gold, which make a gold pick. Or we could say, well, 2 sticks plus, maybe we want to rearrange it in a different way. Maybe we say 2 sticks plus 1 iron. Well, what's that make? What are the products of this reaction? The reactants are the things that go into the reaction. And for our purposes, the reactants are going to be what's over here. So if we put 2 sticks and 1 iron, our reactants are 2 sticks and an iron. And our products, oh look, it's an iron shovel. Well, isn't that convenient? So the name of our product is iron shovel. And we know that an iron shovel has the chemical formula St2Fe. 2 sticks and 1 iron, all bonded together just right. Just so, in just the perfect arrangement. We could do similar things for other stick-iron combinations. Like, what if happens if we have 1 stick plus 2 iron? What do we get? Well, if we have 1 stick 2 iron, everyone knows we're going to get an iron sword. And what's interesting here is that the iron sword is now, in some sense, has the same symbol there, so we're going to do that. And the iron sword has a slightly different chemical formula, St2Fe. And so we know that the iron stick, or the iron shovel, sorry, has the chemical formula St2Fe1, and the iron sword is the other way around. My bad. And the iron pick is this St2Fe3. These are 3 different chemical formulas to represent 3 different substances. And the substances have names. We say the substance's name is iron sword, iron shovel, and iron pick. But we also can say that, it has this formula. It's made of these things. An iron sword is made of these atoms into an iron sword molecule. And then we might have a whole chest full of iron swords. That might be a, block of iron swords, which would be an interesting block to make, but no, doesn't really work here. Nonetheless, we can continue posting iron in different arrangements to get other stuff. For example, we can put 2 iron atoms this way to make a weighted pressure plate. We can put 6 iron atoms like this to get iron bars. So there we go, 5 makes a helmet. And this brings up an interesting point. What is the chemical formula of an iron axe? Well, these 2 sticks, but now it has these 3 irons, but they're in a different shape. If we were to just write that in the way we've been doing this, let's just clear everything. The way we've been doing this so far is that we'd say, well, 2 sticks plus 3 iron is going to make an iron axe. And we'd say that an iron axe has the same chemical formula of St2Fe3, but we already knew that the iron pickaxe has that formula. So how do we resolve this? Well, this is where the idea of molecules having arranged atoms comes into play, and this makes perfect sense in Minecraft. Everyone knows, obviously, that to make an iron axe, you have to put the iron in this shape, but an iron pickaxe, the iron has to go in this shape. This is very much the difference between all of the molecules in your DNA. This is the difference between sugar, all the different types of sugar molecules. This is the difference between lactose and fructose. Lactose in milk, fructose from fruit. They're very similar to this, where 1 or 2 atoms may be moved slightly, even if the overall composition is the same. We would call this an empirical formula. An empirical formula simply says how many atoms of each element are in that compound. And both the iron axe and the iron pick have the same empirical formula. It takes 2 sticks and 3 irons to make either of those things. Alright, so if we had a bucket full of sticks and a bucket full of iron ingots, we'd know that it would take 2 buckets and or 2 stacks of sticks and 3 stacks of ingots to make a stack of axes. It would take the same amount, 2 stacks of sticks, 3 stacks of ingots, to make a stack of pickaxes. They have the same empirical formula, but their structure is different. And it turns out that sometimes when we write these on paper, that just writing empirical formulas often can't tell you the difference between this IA and IP, iron axes and iron pickaxes. This is particularly important when we talked about 2 types of sugars, lactose, let's make that a capital L, and fructose. Lactose and fructose have very similar empirical formulas, but their structures are different. Even closer than fructose is glucose. Both of these have 6 carbons. Oh, I ran out of there. Nope, I still don't have enough space on my side. There we go. Both of these have the same empirical formula, C6H12O6. They both have 6 carbons, they both have the 12 hydrogens, they both have another 6 oxygens, all right? Which is actually, they both have the same empirical formula with the same ratios, which is CH2O. Carbon and water, essentially. Carbon, oxygen, and 2 hydrogens. And these are somehow, okay, so there's 6 of them, but somehow these are 2 different substances. If you're diabetic, you care a lot about glucose and your glucose levels. If you're lactose intolerant, you care a lot about dairy. But just because you're diabetic and you need extra glucose or have to watch your glucose doesn't mean you're lactose intolerant. You can have all of the milk if you're diabetic, maybe. And likewise, maybe just because you're lactose intolerant doesn't mean that you're intolerant to glucose. There is a difference between these 2 structures. And this is an ambitious project, but it would be possible to build structures of the two things here, which I might try at some point, but not in this video. I have a feeling this video has already gone on long enough. All right, so let's review for the moment. We have this chemical reaction where we have reactants and products, and as far as Minecraft is concerned, these are reactants, this is products, we have atoms and elements here, and a substance coming out here. We have empirical formulas, which tell us, how is an iron pickaxe made, and they tell us how an iron axe is made, but they don't necessarily tell us how the atoms are arranged. And that sounds like, why would that matter? Like, you're thinking to your chemistry classes, who cares how the atoms are arranged? I just have to write the right reaction down on the test. But it actually does matter. How the atoms are arranged gives you the difference between that pickaxe and axe. They have the same empirical formula, but they have different structures and different arrangements. And the type of chemistry that cares most about this is called organic chemistry, and we'll get into the names of that in a little bit. But in that type of chemistry, there are different ways of writing these out that would represent, that would better represent what we expect to see. And so in organic chemistry, you might see something that looks like this: CH3, CH2, CH2, CHO. This is a structure in organic chemistry that means something to chemists, that tells us a little bit about how the atoms are structured, whereas just writing C4H7O, this does not necessarily give us the same information. And it turns out that where we put that O actually does matter. If we put that O here versus here, this is now a different compound with different properties, and it's just different. All right, so, but it has the same empirical formula. So we'll come back to structural properties later. Minecraft doesn't have a great way of writing that structural properties down with signs, but it does have good ways of showing it in the crafting grid, and we can make models of them, of course, out here. But I think that's probably a good place to wrap up for the moment. We've talked about reactants and products. We've talked about differences between atoms and elements and compounds and substances a little bit more, and we've shown how we can kind of represent those in Minecraft so that when you're thinking about them on your next test, hopefully it's not too overwhelming. All right, so stay tuned for next time, and stay safe, and don't catch on fire.